Hi, and welcome to this workshop on reimagining the incentivization structure in academia. I'm Cooper Smout, and I'd like to thank the OHBM student and postdoc special interest group for inviting me to lead this workshop. So I thought I'd get started with a quick story about my journey. I did my PhD at the Queensland Brain Institute, and over the course of 5 long and sometimes painful years, I managed to publish a few of my studies as papers. Now, the first paper I published was eye-opening for me because it took 2 years, 5 journals, and multiple rounds of review before it was finally published. And I found myself thinking this is just the most ridiculously slow and frustrating process. And I also found myself feeling pressured to tell a particular story. And that was a story that was significant, novel, and clear, never mind that science is normally quite messy. And this combined with the pressures of a PhD and me questioning my future in academia threw me into a state of disillusionment and a deep depression that lasted a couple of years. Now, I pulled myself out of this depression through 2 things. First, meditation and taking better care of myself more generally. But secondly, discovering hope in the very powerful open science community out there that's already taking big steps towards creating a better system for all of academia. And so I founded a project that I'll tell you about at the end of this talk, but I also spent about the last year of my PhD trying to find funding for this project and ultimately failing. And I reached the conclusion that I could actually spend my time better just generating funds in my own way rather than continuing a traditional sort of postdoc route. And so I left academia once I graduated. I joined an independent institute for researchers called IGDOR, and I started playing poker. Now, this is a side hustle that I'd learned during my undergrad days I was profitable in. And so I continued this up. I picked this up again as a way to fund myself and my open science projects moving forward. Now, happily, earlier this year, a private benefactor heard about me and my work and has offered me a small amount of money that will mean over the next year or so, I won't have to spend as much time playing poker. And I'm planning on putting some of this money towards a new meta-science paradigm that I hope will end up in some innovative tools that I think down the track could play some role in disrupting scholarly publishing. So if you're interested in that part of my story, please ask me during the discussion and I can tell you a bit about what my future is going to look like. In the meantime, I would like to dedicate the bulk of this talk to an open science hero of mine, Dr. John Tennant. John sadly died last year in a motorbike accident in Bali, but he was an inspirational figure to myself and many others in the open science space because he had gone rogue after finishing his PhD and spent the last few years of his life traveling around, giving open science talks, and building a really strong open science community that was dedicated to change, which is called the Open Science MOOC. Now, before John's passing, he made all of his talks openly available via Figshare. And so the vast majority of the slides I'm about to show you are actually taken from John's presentations, both in a kind of homage to him and his work, but also, to be honest, because it was way easier. And I saved a lot of time doing this. And I think this is a great analogy or demonstration of how much easier our lives could be if only we would start sharing our work more effectively. So without further ado, part 1, a global scientific crisis. There are currently 4 major crises in science: access, reproducibility, serials, and evaluation. Access just simply refers to the fact that the vast majority of research remains inaccessible to most people on this planet. Now, back in 2018, around 28% of the scholarly literature was open access, and although this statistic has increased slightly in the years since, when you consider that it's been 25 years since the open access movement began, and we've poured billions of dollars into this movement, I'll let you decide whether that is a success or not. And also, according to the Universal Declaration of Human Rights, access to science is a human right. And by denying people access to this, we are very literally costing people their lives because doctors around the world don't have access to the latest literature. Now, the second crisis is the reproducibility crisis. and most of you have probably heard of the large-scale replication studies that have been conducted in psychology. You may not be aware that they've also failed to reproduce the majority of findings in other fields like genomics, cancer research, and there have also been some large-scale replication studies in cognitive neuroscience that have failed to replicate key findings. So what this is saying is that our current system is failing to help us understand what is ground truth. And without that understanding, it makes it very difficult for ECRs like you and me to build on other people's work. I personally have wasted around 6 months of my life trying to replicate findings that just weren't ever going to replicate before moving on to more fruitful paths in my PhD. And if we step out and look at the bigger picture, we have some incredibly important problems that we need to solve in the coming decades. Chief among them is climate change. And personally, I think that science could play an incredibly important role in tackling these problems. But the longer that we maintain an unreliable, slow, and inefficient scientific system is the longer that we are holding back progress that we could otherwise be making on these crucial problems. Now, the third crisis is the serials crisis, and this just simply refers to the fact that for decades now, commercial publishers have been draining billions of dollars from the research sector every year. The price of subscription journals has outpaced inflation by over 300% in the span of 3 decades, making scholarly publishing the most profitable industry on earth. And although I don't have time to get into all of the scary details here, I would recommend anyone check out Paywall the Movie, which is a free movie you can look at and takes a deep dive into the business of scholarship and how it's hurting us and society in the process. Now, the fourth crisis is the evaluation crisis, and this simply refers to the fact that we are more likely to be evaluated based on where we publish than what we publish. And this kind of publish or perish mentality has a big impact on us early career researchers, from the difficulty it is that we have to publish null results and negative findings, as well as the pressure it places on us to commit questionable research practices like p-hacking or selective reporting. Now, I'm not alone in having experienced mental health issues, and research shows that over a third of PhD students have sought help for anxiety or depression caused by their PhD study. And ultimately, these toxic working environments are causing high rates of attrition, with very, very small numbers of people actually surviving the gauntlet of science to become professors down the track. I think the statistic is less than 1%, depending on what country you're in. Okay, so that ends the roundup of all of the negative part about science. And now I get to tell you about all of the cool, exciting things that are happening in the open science revolution. But first of all, what is open science? Well, open science on the one hand is a set of principles like transparency, reproducibility, and accountability. On the other hand, it's a set of practices like open access and open methods and pre-registration. And yet again, it's a set of values that we might strive towards, like equity, freedom, and fairness. Now, each of these principles, practices, and values occurs within a broader cultural landscape, which is going to have to shift if open science is to become the norm. And this is an infographic that I borrowed from Brian Nosek, who founded the Center for Open Science. And it basically highlights all of the different layers of change that are going to have to happen if open science is to become the norm. And what I want to do is focus first on these two fundamental crucial layers, infrastructure and the easy user experience, and highlight that there are no longer any technological or technical barriers to you doing open science. And this, I think, is made very evident by this awesome infographic, which shows you that every step of the research pipeline, there are tools that are openly available and free to use that mean you can make your research process more open and more collaborative. So this is everything from shared reference libraries like Zotero, to pre-registering your studies, to sharing data, code, notebooks, and protocols, to sharing your preprints once the paper's written, to using open peer review services and publishing open access, and sharing posters and presentations like the presentations I took a lot of these slides from, which were on John's Figshare account. And then finally, through communicating through social media and using alternative evaluation metrics in your resume and website. The point of this is to say that there are no technical barriers to being more open. And so the question is, why are we not actually doing this already? And I think part of the reason is there's this implicit assumption in the scientific community that open science is in some way antagonistic to your career goals. And I want to do my best to quickly dispel that with some data here. So first of all, we have to recognize that open science is not some weird anomaly. It's actually just doing good science. And by comparison, what we're currently doing is not the best possible science that we can be doing. Now, having said that, there's lots of evidence now to show that open science is actually very good for your career. So there are now a large number of studies that have found a clear citation advantage for making your research open access. And this finding extends to open data to show that basically this just makes sense, right? Because if you can get more eyeballs on your papers and your data, then more people can build on those findings, more people can understand what you've done, and ultimately more people can cite your work. And given that citations are the current sort of default for quality or sort of recognition in academia, much as we might like them to not be, this means that making your work openly available is the single best thing that you can do for your career. Now, what about open access fees, you might cry? Well, open access fees, or sort of author processing charges, are actually a sort of artificial invention of the publishing industry. There is actually a free way to make your research openly available called Green Open Access. And what this means is archiving the author-accepted manuscript via a preprint server or your institutional repository, which takes about 5 minutes and is, I would argue, the single best thing that you can do for your career. Now, the second way openness can help you is by getting your work published. So there's this concept in POCR called results-oriented thinking. And what it means is that if you're analyzing your play, you shouldn't focus on the outcomes, but you should focus on the decisions that you made and the information you had available at the time. And this makes sense, right? Because you can't control the outcome. You don't know if a card's going to come that's going to help your opponent, but you might have made the right decision anyway. And this to me is such a clear analogy for what we're doing in science today, because careers are being made or broken based on the results of findings rather than the quality of the work that went into the study. Now, this is, of course, because we peer review studies at the very end of the research life cycle, and there's a relatively new initiative spearheaded by the Center for Open Science and Chris Chambers called Registered Reports. And this aims to add an additional stage of peer review prior to the point at which data is collected and analyzed. And what this means is there's two key benefits to you as a researcher. Firstly, you can now get feedback at an actually useful time when it's not too late to change that critical design flaw that might otherwise ruin your experiment. And secondly, if you get pre-acceptance from one of these journals that have adopted the registered reports format, then it means that they have committed to publishing your paper irrespective of what the findings are. So now you no longer have to pray to the scientific gods to bestow a magical, significant result upon you and your research. You can just rest assured that you've done high quality work and report everything openly and transparency in accordance with your a priori plans. And when I made this slide, I was actually surprised to find that there are now over 30 journals offering registered reports. And so I think this is probably one of the biggest and best things that we can do to change incentive structures within academia, and something we should all be getting on board as quickly as possible. Okay, so there's all these other ways that openness helps you, which I don't have time to get to go through right now, but hopefully I've gone some way towards alleviating your fears about open science and demonstrated that open science can actually be perfectly aligned with your career goals. Now, the question then is, how do we make it normative within cognitive neuroscience? And so I want to spend the remainder of this talk telling you about a platform that I've been developing over the last couple of years that aims to organize collective action in the research community. Now, it's called Free Our Knowledge, and I started thinking about these ideas after discussions with all of my peers, and I quickly learned that everybody was as frustrated as I was with the scholarly publishing industry, but no one felt comfortable taking action on their own. And this is because most people I talked to felt that they had to play the game in order to survive, and that if they sort of went out on their own and adopted some kind of new publishing format or some new journal, for example, then they would be putting their careers at risk. Now, this is a very common story, and the data is there to back it up. There are very widespread levels of support for open science, but relatively low levels of actual adoption. And what this means is that we have a discrepancy between our attitudes and our practice. And it's kind of like penguins, because penguins are flock animals and they don't like acting on their own. And scientists are very much the same. Like, we're scared of being the first to move because there's this sort of concern or implicit worry that it might negatively impact us, whether through career outcomes or even just seeming different and being unusual to our colleagues. But the thing is, we all have similar goals. The evidence shows that we all want to support open science. We're just not doing it because we haven't communicated effectively. And so what Project Free Our Knowledge tries to do is organize collective action on open and reproducible science practices. And it really just asks the question, what can we achieve if we all act together all at once? So the way it works is very much modeled on platforms that have been around for over a decade now, like Kickstarter, Collaction, and so on. And basically anyone in the world can propose a campaign. And this just has to be an action that is an open science related action. And it's something that they want their community to adopt. Something like posting a preprint or submitting a registered report, sharing some data, posting a review to a platform, you name it. Now, when this campaign is proposed, they also propose a threshold at which people will take action. And so now we put this campaign out to the crowd. And at this point, anyone can pledge to take that action if and when the predetermined threshold of pledges is met. So crucially, once someone pledges, they don't have to do anything else, right? Because they're not required to act until we reach that critical mass of support. And this means that they're protected from any kind of repercussions, and they can also pledge anonymously if that suits their purposes. Now, finally, if we do reach that critical mass of support, that's the point at which we list everybody on the website and contact them and direct them to carry out the action together. And the idea here is that by acting together, we can protect one another's interests and at the same time motivate those vulnerable researchers that might not feel comfortable taking action on their own, but would feel comfortable taking action if there was a broader cohort of their peers alongside them. So the way I see this evolving over time is that I think in the early days, these campaigns will be very small and target very simple actions. Even just having sort of tens of people take a very simple action like post a preprint. But over time, as we develop more and more campaigns and this concept grows and more people get involved, I could see these smaller scale campaigns coalescing into larger scale campaigns with hundreds, thousands, even potentially tens of thousands of signatures taking actions all together to create systemic change throughout academia. And I want to bring to attention your campaign that we've posted recently, which is a pre-registration campaign. Now, this campaign asks you to pledge to pre-register a single study in the next 2 years, once 100 of your peers have taken the same pledge. Now, in psychology, we've already got 65 pledges towards the target of 100 pledges, but they're kind of kicking our butt in neuroscience because we've only got 14 pledges so far. So if pre-registration is something that interests you and you would like to support this campaign, then I encourage you to go to freeourknowledge.org and take that pledge today. Now, that campaign might not be for you, and that's fine, but here's the thing. We can develop any campaign we like along any kind of action that you think is relevant to the cognitive neuroscience community, and then we can put it on the crowd and see if it flies. I've listed here some campaigns that I think could be particularly relevant to our community. So submitting a registered report, posting reviewing an article on pre-review, sharing a preprint, or submitting an article to, inverted commas, good journals like eLife PLOS and NBDT. Now, if any of you have ideas, I would love to hear from you, and we can also talk about this in the discussion time after this presentation if this is something you guys are interested in. But I want to leave you with this slide and this message and ask the question, who are we waiting on to usher in the open science future that could be so beneficial for all of us? Because if we look at history, we have to be careful not to make the same mistakes. And I look at the open access movement over the last couple of decades and think, if we're waiting for universities, publishers, editors, librarians to create the change for us, I think we're going to be waiting a very long time. Because it was forecast by Parks back in 2002, based on an understanding of the incentives under the current system, that very little was going to change in the publishing system. And unfortunately, decades later, he's been proven relatively right. Now, at the same time, researchers are the ones who actually take the actions, and so that gives us an incredible amount of power. We have to recognize that we are partly responsible for creating this current system by having built journals into the powerful brands they are today. But with that responsibility and understanding also comes a huge amount of power. If we created this system, we can also uncreate it and create a new system that serves us and our purposes. And I want to highlight as well that ECRs make up the vast bulk of academia. And at the same time, these issues most affect us because we're the ones that will be moving into this system and we're the ones that are being most hurt by the current system. So if we alone as an ECR community could organize around new baselines of practices that we want to support, then relatively quickly in a short amount of time, we could create new norms and kickstart a revolution in academia. And so on that note, I just want to leave you with this quote that I think is particularly apt. Never doubt that a small group of thoughtful, committed citizens can change the world. Indeed, it's the only thing that ever has.